In experiment 5, we found using a closed system that pressure and volume are inversely proportional to each other and directly proportional to temperature and related by a proportionality constant. We also calculated for that proportionality constant, which could be considered equal to the ideal gas constant times moles, because the amount of gas, aka moles, was constant because the system was sealed. So the relationships we found were directly equal to this ideal gas law, which can be observed in many ways, such as rapidly decreasing the temperature of a balloon by dunking it in an ice bath, which will decrease the force of the pressure pushing outwards on the balloon, and you can see as the gas shrinks up because of that. So the temperature decreasing will decrease both of these, and increasing it will increase both of these. If it's a rigid container with a constant volume, increasing this will only increase the pressure. So if you have the temperature constant, then you can easily just observe the relationship between these. And here I have a bag filled with gas and the room temperature is pretty constant. If I try decreasing the volume of this bag, the pressure will increase. And since I've lightly sealed this bag, we can observe the pressure increasing because the force of the pressure will exceed the limit on the seal and break it, and you can hear it coming out. So here are some mathematical uses of this gas law. Just like finding the constant, you can find the moles by dividing the pressure and volume by the temperature, but also now dividing by the ideal gas constant you can look up. You can find, if you know the maximum pressure a system can withstand before taking damage, you can divide this by the maximum pressure and find how small you can decrease the volume before it exceeds that pressure and breaks. And if you have a constant volume system instead, you're trying to find how much heat it can withstand before exceeding maximum pressure, you can divide this side by the moles in the ideal gas constant.